right, so let's take a look at example number 1 and 2 on page number 7. So in some cases, you would be able to do the greatest common factor just mentally. Like you don't need to do your work for it. It's easy numbers, so you don't need to use your prime factorization. So some people would be able to take a look at these numbers and say, well, what's the biggest number that will divide 15, 25, and 35? And they can say, well, 5. Okay. Well, sometimes the numbers can come quickly to you, and sometimes you need to maybe take a look at it and say, okay, no, I need to break this down. So you would do the same thing. You can break down 15 as 3 times 5. So I will write those two prime factors. You will write 25. You will see how you can break down 25. It's 5 times 5, right? So those are the prime factors. It can't go any further than that. And then 35, you'll say, okay, let's see how 35 will break down. It's 5 times 7. So then you'll say, okay, what number will now be, a factor will be common between all 3 of them. So you can say, okay, this 5, let's say, you can only count it once, right? So you can see there is a 5 that is in all 3 of these numbers. So the GCF between them is going to be 5. Okay. So same thing you can do with example B and C. You can take a look at them and say, okay, what is the factor between 18 and 20? Well, it can be 2, and 36 and 54, it will be 18. So if you can do this mentally, any of them, that's great. If you need to do them by a table or by a tree, that is also perfectly fine. Okay, so I would ask you guys to practice trying to do B and see if you can get your answers for them. What I would like to do is do the little bit longer numbers with you, because those are the ones that we really do need to use our prime factorization methods in order to solve them. Okay, so what I'm going to do is I'm going to do part A with you. I'm going to ask you guys to stop the video, try part B on your own, and then resume the video to see if you got the same answer. Okay, so now in order to do the GCF here, I need to first break down 90. So the number that comes into my mind right away is 9 times 10. Okay, if you're having a little bit of difficulty doing this method, maybe the table method might be easier, because you can always start with a prime factor. So you could have started dividing it by a 3 or a 2 or a 5 and then go on to the next step. So if you can't think of any number that will break down, you can always switch to the table. Okay, so neither one of these are prime factors, so I'm going to go and break them down. This works. And this also breaks down to 2 and 5. So this works. So when I'm doing the prime factors of 90, I know it's going to be 2 times 3 times 3 times 5. I just organized it for myself, so it's easier to look for the greatest common factor if they're written in order. Okay. Now 225. I know some of you guys can probably think of how to break it down, and some of you guys are thinking, I can't think of like a number breaking it down, so maybe we want to do a table here. Okay, so try dividing it by 5. Why did I say divide by 5? Because if it ends with a 0 or 5, we know it will be divisible by 5. So when we divide this by 5, it gives me 45. Now it's becoming a little bit more easier. That's another divisibility by 5. So that's by 9. That's by a 3. And then the last one by a 3. So when we hit that, it can no longer be divided. We know that we have got all our prime factors. So then this ends up becoming 3 times 3 times 5 times 5. Okay, so the prime factors are done. Now we're going to look for the greatest common factor, the GCF here. Okay, so the GCF has to be the factors which are common in all the numbers given. In this case, only 2 of them are given. So this 3 is common. So I'm going to write this 3. Then there is another one. So then there's this 3 is also common. So I'm going to write that one down. And then there is going to be another one, which is this 5. So I'm going to write that one down. So these 3 factors are common, and when we multiply them, they become 9 times 5, so that is 45. So 45 is the greatest common factor between 90 and 225. So now what I want you to do is pause this video and see if you can get the greatest common factor between the second one here, which is our 154 and 198. Okay, so hopefully you have given a try and gotten an answer for it. And the answer between this is 22. So how did we get that? The first thing we're going to do is break down these two numbers. Now you could have used one of the two methods. So let's say if I just did a tree diagram on it. So 154 can be divided by 2 times, and then it will give you 77. 77 can be broken down as 7 and 11, and those are the prime factors. So 154 can be written down as 2 times 7 times 11. And then I would do the same thing with 198. This can be divided by, let's say, a 6. So we'll go by a 3 and a 3. Both of these can be broken down further. I'm doing it super fast, but hopefully you've had a time to do it. Take your own time when you're practicing it. And then when I write these down, 3, in order, I can see that there are two numbers that are common between them, this 2 and this 11. So the GCF here is 2 times 11, which is 22.